So 16 and 17 would be these two here. Okay, so the one in relation to the frustum, and one which is the Archimedes Principle question. What I imagine we'll do is we'll be going through some of those past papers this week. Okay, it's quite nice, those past papers, because it's a revision of all the topics we've learnt so far. Okay, so that's why I want to go through it. Now, let's get on with question 16 and 17. Okay, so let's have a look at what question 16 is asking us to do. So in question 16, we are told that we have a cone, okay, that has been comprised of two different shapes. Okay, one of them is a small cone and another cone at the bottom, which has its top removed, also known as a frustum. Now, we are interested in finding the volume of the frustum. Okay, so this question here isn't too tricky. It just involves us first figuring out what the volume of the small cone is, then what the volume of the larger cone is, and then minusing them out. Okay, that's essentially what it's going to be for question 16 here. So what I'm going to do is I'm going to draw out a diagram. Okay, so there's my large cone, and here's my small cone, which I'm going to shade in. Okay, so that's what I know. Now, in doing this question here, okay, I'm going to first name out my two volumes. Okay, so the volume of the large cone, I'm going to refer to as volume 1, and the volume of a small cone, I'm going to refer to as volume 2. Now, let's figure out what volume 1 is going to be given by. If you guys aren't aware, the volume of a cone is given by a third times pi r squared h. Okay, a third times pi r squared h. Now, in having a look at volume number 1, okay, I think we can see that the height is going to be 6 centimeters, whilst the radius is 9. Okay, it's because that the whole diameter is given by 18, so the radius is going to equal to 9. Okay, so it's going to be a third times pi times 9 squared times 6. Okay, let's have a look at what we're going to get when we do that. Okay, we're going to get 508.94. Now you can put that to its exact form, and I believe that would be better if you do that. Okay, so if you decide to put it in its exact form, we're going to get 162 pi. Now let's have a look at volume number 2, which is going to be the small cone at the top. It's going to be a third times pi times the radius squared, which in this situation is going to equal to 3, times the height, which is equal to 2. Okay, so once again, I'm just going to put it in its exact form, and what you're going to get is 6 pi. What's going to be the volume of our frustum then? Okay, the volume of our frustum is going to be equal to 162 pi minus 6 pi, which is equal to 156 pi. Okay, now you can leave it to two decimal places if you wish to, but remember in this question, they want us to express it in terms of pi, so let's keep it in this form here. That is going to be it for question number 16. Let's have a look at what's happening. We've got this rectangle, a rectangular container, and it's been filled with water. Now what you've done is you've put a sphere into the water, and we want to calculate the rise in water level. Okay, now you guys should know from primary school the concept of Archimedes Principle. What it is basically is when you put in a volume into a body of water, that body of water will rise by that exact same volume. Okay, so I think the key to doing this question here is going to be working out what the sphere is going to equal to. Okay, what is going to be the volume of the sphere? Well, we're told that the sphere has a radius of 3.5 centimeters. Okay, so what we're going to do then in that case is write out the formula for the volume of a sphere. There it is there. Okay, 4/3 pi r cubed. Okay, and we punch into our calculator the value of r, just like that there. We're going to get 343/3 pi. Okay, so that there is going to be the volume of our sphere. Now, let's have a look at the capacity of our water at the moment. Okay, we're not really interested in the capacity of our container. Instead, we're interested in the capacity of the water, okay, because we want to see how much. Okay, so you do 12 times 11 times 8. And what you're going to get for your answer when you do that is 1,056 milliliters, or 1,056 centimeters cubed. Now, let's have a look at what the total capacity, okay, or the net capacity of our water plus our sphere would be. So you just do 1,056 and you add that with 343/3 pi. Okay, and what you're going to get when you do that is 1,415.19 centimeters cubed. That there would be our answer. Now, we're not done yet though. Okay, keep in mind we're not done yet though. The reason why is because we need to figure out what the water level is. Okay, so it's great that we have the net capacity of our water in our sphere. Okay, it's going to be crucial in answering the question, but we're not done yet. Now, if you guys know and remember from year 8 and year 9, one of the things I've always said about volume is it's given by this here, okay? Volume is equal to cross-sectional area times height. Now, what we know is we know the volume of our water, right? 1,415.19. Okay. If we decide to sub that into our formula here, which is V is equal to SCA, and then we figure out what our cross-section is going to be equal to, I think we can now figure out what our height is going to be. So let's go ahead and do that. So I'm going to sub in my capacity into volume. 1,415.19 is going to equal to the cross-section, which is 12 times 11 times my height. That means that my height, therefore, is going to be given by 1,415.19 divided by 132. And what you're going to get for your answer is going to be 10.72. What is going to be the rise in water level? Well, what's going to be 10.72 minus 8? You're going to get this as your answer, 2.72. And that's it there. So that there is all you have to do.